Hello, and welcome to my channel. In this lesson we are going to learn about most confusing concept in thermodynamics, that is internal energy. Think about a pot of water, the molecules moving around slowly, colliding gently with one another. So the total energy of water represents internal energy. Now, you turn on the stove, heat energy begins flowing from the flame into the water. Suddenly the molecules moving faster start colliding harder, bouncing around with more energy. As a result, the internal energy of the water increases. So what is internal energy? The internal energy of a system is the total energy contained within the system due to the motion and interaction of its particles. The total internal energy of a substance is the sum of the kinetic energy of its particles and the potential energy between those particles. Kinetic energy is the energy of motion. Even though we cannot see them, every particle in matter is constantly moving. It includes three types of microscopic motion. Translational motion, in which particles move in straight lines, from one place to another. Rotational motion, in which particles spin or rotate around their own axis. Vibrational motion, in which particles vibrating back and forth about a fixed position. Together these motions make up microscopic kinetic energy of the system. Potential energy is the stored energy due to interactions between particles. It comes from chemical bonds that holds atoms together in molecules, intermolecular forces such as hydrogen bonding. Even nuclear interactions at the atomic level. All these interactions makes potential energy of system. Let me explain some properties of internal energy. Internal energy is a state function. What mean by state function? A state function is a property of a system that depends only on its current state. It does not depend on path taken to reach that state. Suppose we have 1 mole of liquid water at 25 degrees Celsius. Its internal energy is U1, that is fixed for the state. Now let's bring the water to 100 degrees Celsius. The internal energy will be U2. The change in internal energy is represented by delta U, which equals to U2 minus U1. This value depends only on the initial state and the final state. It does not matter whether you heated the water directly with a flame or you placed it in the sun. As long as the final state is 100 degrees Celsius, the internal energy is the same. Internal energy is an extensive property. Why do we say that internal energy is an extensive property? Because the total internal energy of a system is directly proportional to the amount of matter present in it. If we double the mass of a system, keeping temperature and other conditions the same, the internal energy also doubles. Suppose you have a pot of boiling water at 100 degrees Celsius. Let's say its internal energy equals U. Now you take another pot with double the amount of water, but still at the same temperature. The temperature stays the same because temperature is an intensive property. Because it doesn't depend on how much water you have. But the internal energy becomes doubled because the total amount of water has doubled. The most important point to remember, internal energy is not fixed, it can change. But how does it change? There are two main ways, heat and work. Heat is the transfer of energy due to a temperature difference. When a hot object and a cold object are in thermal contact, heat flows from the hot object to cold object. This heat transfer causes decrease in internal energy of hot object and increase in cold object. This process continues until both objects reach the same temperature. Work is energy transfer when a force acts through a distance. For example, when a gas expands against an external pressure, it pushes back the piston, so that is work done by the system. First law of thermodynamics explains how to measure the change in internal energy. The change in internal energy is represented by delta U. That is the sum of Q, heat added to system, and W, work done by system. That is product of force and distance moved. There are different kinds of work. In chemistry we mostly deals with pressure-volume work. In pressure-volume work, force becomes pressure, while distance moved becomes change in volume. Imagine a gas inside a cylinder with movable piston. When you supply heat energy, the gas particles move faster. As a result, internal energy increases, and piston is pushed upward. So the gas does work on the surroundings, that results change in volume. Thanks for watching. Don't forget to like, share and subscribe to our channel for more educational content.